Welcome to the equivalent fractions video. This is for level 1 and level 2 maths, going over the basics. So an equivalent fraction is a fraction that is the same as another fraction. We've got to be able to compare them for your exam, so this is why we're going to learn how to compare fractions in this video, and then later ones will be comparing fractions with decimals and percentages. So a quick reminder, the top number of a fraction is called the numerator and the bottom number of a fraction is the denominator. Let's take a look at our first fraction, a quarter. So imagine you've got a pizza, you divide it into 4 equal pieces. You take one of them, you've got a quarter. If I represent that in this drawing I've made, I've got 4 equal boxes here, I shade one in, that there, that's my quarter. But let's say I want to know, well, what if I cut my pizza into eighths instead? Well, I'm going to draw my diagram again, but this time I'm going to make it into eighths. Notice that my diagrams, both of those those wide rectangles are the same width, but now they're just cut into 8. When I do my shading, I'm only going to shade up to the same point as my quarter. So when I shade in, you'll notice I've got one there and one there. So that means that a quarter is the same as 2/8. What does that actually look like as a question? Well, all they would give you is 1/4 equals how many eighths, and you've got to fill in the blank. When it comes to equivalent fractions, you're only allowed to times or divide. The idea of adding and subtracting fractions is a completely different skill, and that's a level 2 skill. So, for doing equivalent fractions, we can only times or divide. Now, to get from 4 to 8, I'm going to have to times, and I'll do it by 2. So whatever you do to the bottom, you do to the top. So 1 times 2 is 2, and that's why 1/4 is the same as 2/8. So let's try another one. This time I've got a third, so imagine your pizza is divided into 3 equal pieces. You have one piece, that's a third. As I shade in my diagram, one of these boxes, 1 out of 3 is shaded. What if I wanted that as an equivalent of ninths? So if you did a pizza into 9 equal pieces, I'd be really impressed. I think I might have to get my protractor out. But anyway, let's say that you've done it. How many pieces would you get? So I've drawn my 9 pieces, and I can only shade up until the same point as the third. So shading that in, I've got 1, 2, 3. So that's 3/9. So 1/3 equals 3/9. What would it look like as a question? Literally, third equals how many ninths? And you've got to fill in the blank. Well, without a diagram, remember you can only times or divide, but to get from 3 to 9, I'm going to have to times by 3. And whatever you do to the bottom, you do to the top. So 1 times 3 is 3. Let's have a go at these. It's exactly the same thing, but without the diagrams. So remember, all you can do is times or divide. Now in this case, we're going to a higher denominator. So from a lower denominator, that's 4, to a higher one, which is 16. And if you're going from a lower to a higher, then you're going to be timesing. Okay, so 4 times what equals 16? Well, it's actually times 4. Whatever you do to the bottom, you do to the top. So 1 times 4 is 4. So 1/4 is the same as 4/16. If you draw out the boxes, you'd get 4 out of 16 is the same as 1 out of 4. Our last one down here, to get from 15 to 30, you'd have to times it by 2. Well, you do the same to the top. So 3 times 2 is 6. Equivalent fractions, we've been going from a smaller to a higher number, but let's go the other way this time. So I've got 5/10. So here are my boxes. If I shade in 5 of them, this is what it looks like. Well, this time we're going to a fraction which is lower, and it's a 2, so that means halves. So if I draw out my boxes this time, it's the same width, but there's only 2 boxes. Now if I do my shading in, it can only be to the same place as the 5/10. So that means that only one of these boxes gets filled out. So 5/10 is the same as a half. What would it look like as a question? Here we go. You've got to now do it without the diagrams. Now we know the answer, but remember all you can do is times or divide. Sorry, that's not a divide, that's the number 2. So let's get rid of that. Don't know what I was thinking of then. That's better. Now to get from 10 to 2, we're going to have to divide this time because we're going from a bigger number to a smaller one. So it's actually 5. 10 divided by 5 equals 2. Whatever you do to the bottom, you do to the top. 5 divided by 5 is 1. So 1/2. Now you need to do it without the diagrams. So we're going to a smaller denominator. So we're only going to be dividing. So 18 divided by something equals 9. Well, it's actually 2. So do the same to the top. 6 divided by 2 is 3. The bottom one here, we're going to be dividing. So 20 divided by something equals 4. Well, actually it's 20 divided by 5 equals 4. And do the same to the top. So 5 divided by 5 is 1. Notice that the bottom and the top have been divisible by you can divide it by the same number and you get a whole number. If you get something like, oh, I've got to divide this 5 by 6, that's not going to work. So you can't take that any further. But that's the next thing that we're looking at actually. So the next thing, which is simplifying. So simplifying is when you get in the denominator as low as possible. And if you do that, obviously the number on top is going to get lower with it. So instead of us saying, well, I want the bottom number to be this, you have got to decide what the bottom number is going to be. Now, your strategy for doing this is usually, what do both sides divide by? Do they divide by 2? Do they divide by 3? Do they divisible by 4? Is it 5? Etc, etc. So it is a bit of a sort of try it and see, and it does rely on your knowledge of the times table as well. So 22. 22 is divisible by 2. Any number that has an even number in the end is divisible by 2. So we'll probably go with that first of all. So 22 divided by 2 is 11. 16 divided by 2 is 8. So I can't take this any further. 11 is then, it's only divisible by itself, or 1, but that doesn't help me at all. So I've simplified that down to 8/11. Let's try the next one. So 45 over 50, I'm trying to simplify it down. Looking at these, both the numbers end in a 0 or 5, which means it's divisible by 5. So 50 divided by 5 equals 10. Let me write that in. And if I do the same to the top, 45 divided by 5 is 9. So we get 9/10. That's quite a nice fraction to have. Looking at 9/10, I can tell you that that's the same as 90%, which is quite a nice one to do. So this is your chance to have a try at simplifying. So pause the video, write them down, have a go, and then compare them with what I've got. So here we are. The top one, 9/27, they were both, you could either divide both sides by 9, but if you didn't know that, you probably would have divided each side by 3, and if you do that, you'll find that you could have then divided by 3 again. So you might be simplifying down in stages. Then 10 over 45 was 2/9. Each side was divisible by 5. And the last one we actually did before, so I don't think there wasn't much point in that one being in there anyway. So last but not least, this is what we've been building up to. Which fraction is bigger? So is it 6/18 or 5/9? And they usually give you ones that aren't immediately obvious. Both the denominators are different, so you have to change these fractions so that they are the same. And if they're the same, we can then compare them, know which one is bigger. So there's two things I could do. This 18, I could make it into 9ths because at the bottom they're divisible by 2. Or I could take the 9th and make it into an 18th because I can times it by 2. So let's see what happens. I'm going to divide each side by 2. So I'm sorry, let me say that again. I'm going to divide this one by 2. So 6/18. I'm going to make that into 9ths. So 18 divided by 2, as we know, is 9. The top bit divided by 2 equals 3. Now these fractions are the same, so it's a bit easier now to compare. Which is bigger, 3/9 or 5/9? Well, this is the bigger one here. Let's try another one. So 17/20 or 4/5, which one is bigger? I got a choice. My 20, I could divide that by 4. That will make the bottom number of this one here into 5. The only problem with that is this number here, that doesn't divide by 4, so that isn't going to work. So I can't make this 20th into 5 without affecting that top number. But let's look at this side here. So if I want to make 5 into 20ths, I times by 4. Well, I can times the top number by 4. I can times any number by another whole number. So let's do that. We're going to convert 4/5 into 20ths. So to get from 5 to 20, we've got times by 4. I'm going to times by 4 on the top. That gives me 16ths. So which fraction is bigger? 16/20 or 17/20? Well, it's the 17/20, which is that one. So it's time for you guys to have a go. Pause the video and tell me which fraction is smaller. Okay, let's try it. What could I do? I could make this 35. I could bring this fraction into 5ths. To do that, I would have to divide by 7. The only problem is I can't divide this top one by 7 without giving us a decimal number, so that's not going to work. So we're going to make this bottom number here, we're going to make it into 35ths. So right, 3/5 is the same as how many 35ths? Times it by 7, do the same to the top. 3 times 7 is 21. So which is bigger? 21 over 35 or 27 only 35? Well, it's 27 over 35. So, oh, that's the bigger one, isn't it? Actually, what we wanted, silly me, was the smaller one. Let me take that back. Made a mistake, but I'm not re-recording this again. Which is the smaller one? This is the smaller one, so 21 over 35, that was this one here. So 3/5 was the smaller fraction. That is the end of this quite long video. Well done.